Dear GATE aspirants, welcome to Veda GATE Academy. Hope you are perfect with mesh and node analysis DS and the respective methods in each analysis. And even you are perfect in verifying power law for every circuit. In this session, let us go with source transformation. What is this source transformation, sir? It is a network simplification technique. What, sir? It is a network simplification technique which reduces number of nodes present in the circuit. Which reduces what, sir? Number of nodes present in the circuit, and is applicable only for practical sources. And is applicable only for practical sources. In short, we'll give the statement like this. Yes. Source transformation. It is a network simplification technique which reduces number of nodes present in the circuit and is applicable only for practical sources. That is the reason why I have taken a practical voltage source here. I have taken a practical current source here. Before getting into further discussion, tell me, sir, what are the sources that are available for us? Ideal voltage source, next, practical voltage source, ideal current source, and practical current source. Ideal voltage source, is it available for us in the market? No, not available. Practical voltage source, yes. Ideal current source, no. Even practical current source, no, yes. Even practical current source, no. In your unlocked subject, in your power electronic subject, you will be seeing some current sources here. The real application you will be discussing there. Done for you? Right. So for me, as of now, what is available? Practical voltage source is available. But in some applications, we will be going with practical current source. Some discussion, some analysis we will be doing with practical current source, sir. So how to get that practical current source? Practical voltage source can be converted into practical current source. How to convert that? To convert this into this, yes. What should the value of Is? Or to convert this into this, what is the value of Vs? That is our real discussion here. Find Vs, right. Let us connect some load here, sir. Let us connect a load resistance of value RL. Even here, let us connect load resistance of value RL. To convert practical voltage source into practical current source, few conditions has to be satisfied. What are those few conditions? Open circuit voltage should be same. Open circuit voltage in this circuit should be same. Next, second point. Short circuit current should be same. Short circuit current should be same. And lastly, third condition, resistance viewed from the load terminals. Resistance viewed from the load terminals should be same. Okay, simply I'm writing, sir, or for clarity purpose, let me put some A and B over here, and let me put some A and B over here. Resistance viewed from AB terminals, RAB, should be equal to R or RS here. Fine. These three conditions has to be satisfied. Then only I can convert this circuit into this or this circuit into this. So let us find these values here. What is the value of Is? What is the value of Is? Okay, let us find that. What is this open circuit voltage, sir? Can you tell me? If I remove this, let me remove this DS. Let me remove this. Yeah, I am removing this. This is removed. Can you tell me what is the value of VAB here? Open circuit voltage is nothing but what? VAB, sir. Once this is open circuited, what is current here? 0 ampere. This source is not doing any work. What is VAB? Started here, go to be following KVL sign convention. In this circuit, open circuit voltage is VAB. Which is how much, sir? Vs. Next, in this circuit, let us open circuit this. Let us open circuit this. Yeah. Why if this is open circuited? Can you tell me what is VAB here, sir? When this is open circuited, this Is current flows like this. Current is what here? Is. What is this current, sir? Is. Can you tell me what is VAB? Started A, go to B, following KVL sign condition. See, I can't go like this. Why? Because I don't know this voltage. But I can go like this. If I go like this, what is this voltage, sir? Is into Rs. This voltage is simply Is into Rs. Here I can substitute. What I can substitute here? Equals to, yes. What is VAB here, sir? Is into Rs. So what you got? By equating open circuit voltages, Vs equals to Is into Rs. Next, second case. Let us go with short circuit current. Let me take green color pen. What is short circuit current here? If you short this, how much current flows here? Come on. Vs by Rs. Next, similarly, if you short these two terminals, how much current flows here? No current flows in this branch. Why? Because current always prefers low resistive path. I also discussed similar structure when discussing sources. Here, what is the current, sir? Is. In my very first circuit, my short circuit current is Vs by Rs. In my second circuit, my short circuit current is Is. If you observe, these both formulas are same. Vs equal to Is into Rs here. Is equal to Vs by Rs. Means what is the conclusion here? The value of Is is Vs by Rs. If you want to convert this into this, the value of Vs is what? Yes, Is into Rs. Lastly, what is the point, sir? Rab should be equal to Rs. Means resistance looking from these terminals. Resistance looking from these terminals by making sources 0. Replace this source with this internal resistance. With its internal resistance means Rs only, na? Next, here replace this source with its internal resistance means what? Rs. Or you can also understand like this. If you consider this as the source, only this as the source, and this has some exclusive resistance or external resistance, replace this with 0. Rs plus 0 is Rs only, na? Rs. Next, similarly, if you replace this with infinity, looking from these terminals, only Rs. Got it, dears? Fine. These three conditions has to be satisfied. Then I can convert this practical voltage source into practical current source and practical current source into practical voltage source. But what should be the value of this, sir? To convert this into this value should be what? Is into Rs. Or to convert this into this, what should be the value of Is, sir? Vs by Rs. This Vs by Rs gives this Is. Clear? Right? In simple way, we can also understand source transformation like this. Let me slide this upside. Let us take some practical structure and analyze this source transformation. I am taking a 10 volt source, a 1 ohm resistance. My load resistance is some 9 ohm, say 10 volts, 1 ohm and 9 ohms. Can you tell me how much current flows here, sir? 1 ampere. What is the value of this voltage drop here? 9 volts. And can you tell me how much current flows here? 1 ampere. What is the value of this drop here? 1 volts. How much current enters negative terminal of supply? 1 ampere. What is the power delivered by this source? 10 watts. Power delivered by this source is what, sir? 10 watts. Can you tell me what is power absorbed by this resistance here? 9 watts. What is power absorbed by 1 ohm here, sir? 1 watts. Okay? Right. So, Telegan's theorem is verified for this problem. I can also say verifying power law is done. Power law is verified for this problem. Next, I want to apply source transformation for this structure. How we can apply? Source transformation is applicable only for practical sources. For this portion, happily, I can apply source transformation. 10 volts, 1 ohm. Simply, I can replace this with what, sir? 10 ampere source. A 10 ampere source, in parallel with what? A 1 ohm resistance. But what is my load resistance, DS? 9 ohms. Please tell me what is the value of current that flows through my load. What is the load current here? 10 into, by current division please, opposite resistance. 1 by total, 10. How much current is flowing here? 1 ampere. If this is 1 ampere, what is this voltage? 9 volts. Tell me, sir, how these two elements connected? In parallel. What should be this voltage, sir? 9 volts. 9 volt 1 ohm. How much current should come here? 9 amperes. 10 amperes dividing like 9 ampere and 1 ampere. Perfectly, casely satisfied. Lastly, sir, tell me what is this voltage? 9 volts. Please tell me what is power delivered by this? 10 amperes into 9 volts. How much? Power delivered by this is 90 watts. What is power absorbed by this? V into I. 9 volts into 9 amps. How much? 81 watts. What is power absorbed by this? Power absorbed by this I square into R. How much? 9 watts. From here, I want to give one beautiful conclusion, sir. What is VIP at my load resistance? 9 volts. 1 ampere, 9 watts. What is VIP at my load resistance here? 9, 1, 9. Here VIP, both are same. But if you observe, what is power delivered by this source? 10 watts. What is power delivered by current source here? 90 watts. What is power absorbed by source resistance here? 1 watt. What is power absorbed by source resistance here? 81 watts. What is the conclusion here? Source transformation is applicable only load point of view. Source transformation is applicable only load point of view, sir, but not what? Source point of view. Only this load point of view, yes, source transformation is applicable. Done, yes? Clear? Right. I can also give one best example to you. We are twins, sir. Okay? Right. Fortunately or unfortunately, we are twins. We are twins. Say, let us assume. Okay? Say means let us assume. Right. My name is practical voltage source. The faculty or the network sir who taught you yesterday or day before yesterday mesh analysis and nodal analysis is my brother with the name practical voltage source. Whoever come to class, whoever teach for you, you don't mind or not? You don't mind. Reason? Whether it is practical voltage source or practical current source means whether it is me or my brother, yes, appears similar, teach in a similar way. So what happens, sir? Whatever the load, whoever the load, who are looking into classes here, they don't get any disturbance. They will understand the concept clearly. So that is what I am saying here. RL, students. Practical voltage source, my brother. Practical current source, it's me. Okay, whether practical voltage source or practical current source, whatever the source that is connected to my load, it draws same current, same voltage, same power. Got it? Right. So this is what one conclusion here. From this, Indian authors modified explanation of source transformation like this. Might be in your colleges, you have learned like this, DS. You have learned the source transformation by equating the load currents Vs, Rs and the load current. Even here, sorry, it is a practical current source, right? Yeah. Let us take one practical current source here. Practical current source Is, Rs, IL. What is IL here? Vs by Rs plus RL. What is IL here, sir? Let us call this as some RL. Huh? What is IL here? Is into Rs by, come on, fast. Rs plus RL. By equating these load currents, if you are equating these load currents, what you are getting, sir? Vs by Rs plus RL equals to Is into Rs by Rs plus RL. This gets cancelled. Vs equals to Is into Rs. Is equal to Vs by Rs. Okay? Right. With what confirmation, sir? Source transformation is applicable only load point of view, but not what? Source point of view. Done? Right, sir. Oh, now let us go to one problem and analyze or clearly understand the source transformation. Suppose the structure given like this. Structure given like this. Can you tell me what is VAB? Can you tell me what is VAB? Okay, so give the values. Fine. Let me take some 6 volts here, 3 ohm here, and 4 volts here, and some 2 ohm here. Okay, right. Can we convert this into single equivalent source? Yes, we can convert. Observe carefully and tell me yes. Can I apply source transformation for this? Yes. Can I apply source transformation for this? Yes. Yes, I can apply. So, if you apply source transformation, can you tell me 6 volts, 3 ohm? What do you get? Current source, practical voltage source converted into practical current source. In parallel with, what is the resistance, sir? 3 ohms. 6 volts, 3 ohms. I equal to V by R. 6 by 3. How much current here? 2 amperes. Next, convert this into current source. What do you get, sir? You also get a current source of value 2 amperes. Why? Because V by R, 4 by 2, 2 amperes in parallel with 2 ohms. In parallel with 2 ohms here. Right? Yes. Now tell me, currents in parallel, we can add or not? Currents in parallel, we can add. This is 2 amperes. Even this is 2 amperes, sir. Yes, we have not written. This is 2 amperes. Currents in parallel, we can add. Currents are in same direction. 4 ampere current source in parallel with, what is the resistance? Equivalent resistance, please. Equivalent resistance, sir. 3 is connected in parallel with 2. How much? 3 2s, sir. 6 by 5. Finally, VAB is 4 amperes will flow here. VAB is what we can write. Started positive, go to negative. Directional branch current same. 4 into 6 by 5 volts. 4 into 6 by 5 volts. This is what the answer. Some 4.8 volts. Sir. Okay. Right. So this is how we apply source transformation. And let me take one more circuit and apply source transformation, sir. Can you tell me what is the short circuit wire current? Resistance here, yes. Current source in parallel with the resistance. And I am asking you what is the short circuit current. Given some 2 amperes, some 2 ohms. Call some 3 amperes and 3 ohms. And let us get the value of this I. How shall we do this? Some structures, no other option, sir. We have to go with the source transformation. No other option. Okay. Though it is a multi-source problem, we have to go with the source transformation. Next. Can you apply source transformation, sir? Yes. Students used to have one doubt. What doubt, sir? We all know that this arrow mark current source is replaced with voltage source. But what should be the polarities of that voltage source? What polarities we have to put? That is what students used to ask me. Arrow mark upside, na, sir. Arrow mark upside means, yes, the polarity is positive at the top, negative at the bottom. Next, resistance. The same resistance which we consider. Resistance. What value of voltage source? V equals to I into R. How much? 4 volts. Series with what? 2 ohms. Next. Even let us convert this practical current source into what? Practical voltage source. Arrow mark upwards here. Plus at the top, minus at the bottom. And a 3 ohm resistance like this. This is some A and this is some B. Here what is this, sir? 3 3s are 9 volts resistance, 3 ohms. Resistance, 3 ohms. Now tell me, sir, if yes, what is asking for? Short circuit current. Na? Let us short these 2 terminals. Come on. Tell me, sir, what is the value of this I? Say some I is flowing here. How we can write, sir? 9 equal to started positive, go to negative following KVL sign convention. Entering it minus 4. What is the total resistance, sir? 3 plus 2, 5I. From this get the value of I, which is 1 ampere. 9 minus 4, 5. 5 by 5 is 1 amperes. So these are few structures where we have to apply source transformation DS. Okay? Right. Let me take one more structure. Explain source transformation. One best structure. So let me take some big structure and explain source transformation. Resistance, voltage source. Resistance, here given a current source. Circuit has become bigger. Let me compress this. Yeah. Hope it's visible to you, yes. Let me take one more practical voltage source here. Let me take one more practical voltage source with reverse polarities. And I am asking you to draw single equivalent practical voltage source with respect to AB terminals. Either voltage source, current source, your wish, sir. 6 volts, some 3 ohms here, some 2 amps and 2 ohms. 6 volts, 3 ohms, 6 volts and 3 ohms. Yeah, the value is given like this. Say, come on, tell me, sir. What is the value of VAB or not value of VAB? Exam is asking draw single equivalent practical voltage source or current source with respect to AB terminals. Even examiner can also ask VABDS. Once we get single equivalent practical voltage source or practical current source, can't we calculate VAB? Yes, we can calculate VAB. Let us try to proceed further. Come on, sir. What shall we do this? Many students, they will be thinking like, these two, they will be converting into voltage source, practical voltage source, and they will be seeing the circuit. You see the circuit for whole day, you don't get the answer. Okay. Even, sir, though I convert this into voltage source, I can do the problem, sir. Yes, you can do, but not now, sir. Not at this stage, a bit later. Presently, we are in first class. Let us go to some 6th class or 7th class. Then easily we can understand. In network subject, I am saying, again, don't say, sir, we are in engineering, 2nd year, 3rd year, BTech completed. Don't say that. In network subject, yes, we are in low level, first class. Still we are at first class. Right? We are at low level DS. LKG over, UKG over, we are at first class. So, how to get the value of VAB or sorry, how to draw single equivalent circuit here. Let us convert this practical voltage source into practical current source. Let us convert this into practical current source. Let me put this circuit here. Hope the screen is stable to you. Yes, right. 6 volts, 3 ohms. We can convert into, yes, it is a practical voltage source. Checking points, please. Yes, it is a practical voltage source. We can convert into practical current source. Come on, sir. Current source arrow mark, upwards or downwards? Positive polarity at the top means upwards. Simply, I can draw here a practical current source of value 6 by 3. How much? 2 amperes in parallel with, come on please, a resistance of value 3 ohms. Next. Here one more resistance is there, 2 ohms. One more resistance is there, 2 ohms. Next. Again, in parallel with 2 amperes. In parallel with 2 amperes. Here we have a terminal point which is A. Next, clear? Similarly here, dears, 6 volts, 3 ohms. Let us convert this into current source. Arrow mark upwards. Why upwards? Positive polarity at the top. 6 by 3. V by R, how much? 2 amperes. In parallel with what? A resistance of value, how much, sir? 3 ohms. Resistance of value 3 ohms. Next, 6 by 3. Resistance is 3 ohms, but current source here, very, very important, upwards or downwards? Positive polarity is at the bottom. Positive polarity at the top means, yes, we put in the upward direction. Positive polarity at the bottom means, when we convert this voltage source into current source, arrow mark in the downward direction. Arrow mark in the downward direction. Clear, dears? Positive polarity at the top, arrow mark upwards. Positive polarity at the bottom, arrow mark downwards. Similarly, arrow mark downwards, converting into voltage source, positive polarity at the bottom. Arrow mark upwards, converting into voltage source, positive polarity at the top. Clear? Done. Yes, here finally what we do is, we replace this with a current source, arrow mark downwards. What is this point, please? B. What is this point, sir? A. What is this point, sir? A. Okay? Clear? Right. Next. Observe carefully, please. If you observe carefully, here how all the elements connected in parallel. Here all the elements connected in parallel. Let me put this source value, sir. What is this value, ma? 6 by 3. How much? 2 amperes. 6 by 3 is 2 amperes. So, how these two connected, sir? In parallel. How these two connected? In parallel. Current source in parallel, we can add. Currents in parallel, we can add. 2 ampere coming like this. 2 ampere coming like this. Still students will be having doubt. Sir, why current in parallel we can add? So now please, how these two connected in parallel? We can replace with a single equivalent resistance. Yes or no? This 2 ampere coming like this. This 2 ampere coming like this. Total 4 ampere going in this single resistance only, na? Even that I can replace with single current source and single resistance. Yes. Same 4 amperes will flow. Okay. That is the reason why we can add parallel currents. So here we can add this to 4 amperes. Here 2 ampere going upwards. Here 2 ampere coming downwards. So now please, if you compress this like a single node, if you compress this like a single node, you please draw this like a single node. Okay, then you'll understand. 2 ampere entering into this node, 2 ampere going out of the node. No current flows through this resistance. Okay, sir. So I can draw this structure like 3 2 3 3, right? 2 2. Okay. Finally, I can draw this structure like a single 4 ampere current source at the top in parallel with 2 parallel 3. How much? 6 by 5 ohms. Here my A terminal is there. Whereas here 0 amperes in parallel with 1.5 ohms. In parallel with 1.5 ohms. Further, how we can proceed, sir? Further, how we can proceed? Yes, we can apply source transformation here. 4 amperes, 6 by 5. I can replace this with a voltage source. I into R, 24 by 5 volts. Series with 6 by 5 ohms. 6 by 5 ohms. Next, here, 0 amperes into 1.5. How much? Plus minus 0 volts. What is the resistance value, sir? 1.5 ohms. Finally, you can add all this and you can draw a single equivalent series circuit. Single equivalent series circuit. Find, yes? Clear? Have a look at this, please. Right. Finally, what is the answer? 24 by 5 volts in series with 6 by 5 plus 1.5. Add these two resistances, you will be getting the value, sir. Okay. Some students still looking at the circuit, they will be getting one more doubt here. What is the doubt? Yes. What they want to do? They will feel all these sources are in series and they want to add this 6 and 6. Tell me, sir, to write a single equivalent voltage source, are they in series? Are they in series, sir? No, they are not in series. Why they are not in series? Here current is not same because of this wire. Because of this wire, current here not same. This is source, they are not in series. Clear? Right. Students are asking, sir, please give some homework. Okay, sir. What homework I can give here is, let me remove this source over here. Let me join these two. And I want to give as a homework. Homework problem. Draw single equivalent series circuit or parallel circuit. Either practical voltage source or practical source. It's up to you here. It is up to you. I am removing this. Please take this circuit and tell me what is VAB or single equivalent series circuit and practical circuit. Done? Right. So for the given question which you have done till now, if examiner asks VAB, what is VAB, sir? Can you tell me what is VAB? This is A, sir, and this is B. Will any current flows in the circuit? Yes, no current flows in circuit. Current that flows is 0 amperes. What is the value of VAB? Start at A, go to B, following KVL sign convention. How much? 24 by 5 volts. 24 by 5 volts is your answer. Done, sir? Right. So this is what source transformation. Now let us take some questions and analyze perfectly the source transformation or get some better clarity on the source transformation. Very important, sir. I want to make one note here after doing this problem. Right. So here values given 28 ohms. Yes, relax, dear, relax. 5 amperes, dear. 8 ohm resistance. 28 ohm resistance, and here some downward direction current 10 amperes and 4 ohms. Examiner's interest is to find the value of current I. How you will be doing this problem? So from here the analysis which you are doing, very important. Very important, sir. Okay, right. What are the techniques we have studied so far? What are the techniques we have studied so far? Please tell me, sir. Yes, or let me write here. Voltage division, yes. Current division, nodal, mesh, source transformation, star delta. These are what the techniques we have studied so far. Can I go with VDCD techniques? Nahi. Why? VDCD techniques applicable only for Ek Niranjan problems. Single source problems. Can I go with nodal? Sahi. Can I go with mesh? Yes. Can I go with source transformation? Yes. Can I go with star delta? No. Why star delta? No, sir. Is there any star branch to convert into delta? No. Is there any delta branch to convert into star? Yes. We have a delta branch here, but still we can't convert into delta. But still we can't convert into star. We have delta branch here. I can't convert into star. Reason? This is my target branch. My target branch should not be disturbed. We don't have any right to disturb the target branches, dear. We should not disturb. Very important point, sir. Target branch should not be disturbed. What is my target branch? Here I want to find current. This is my target branch. We should not disturb the target branch, sir. Examiner asking for this circuit, for this resistance, what is current in this direction? Whereas if we convert this delta to star and we say some other current, no use. You get minus 1 by 3 marks. Okay? Done. Now let's go with first nodal analysis, or first let's go with mesh analysis. Come on, sir. Mesh analysis. Yes, we start with what method? Super meshes are there. We start with CD method. And we stop after finding what? Node voltages. If you want to find node voltages, it is up to you, DS. Okay? Let me copy this circuit for one more time. Copy this circuit for one more time. Copy. Yes, copied. Okay. We are in this page. Now let's go with first mesh analysis CD method. 5 amperes coming like this, I amperes going like this. What is this current, sir? 5 minus I. I coming like this, 10 going like this. What is this current? Come on, engineers. I minus 10. I minus 10 coming like this, 10 adds this. What is this current? I. 5 minus I coming like this, I adds this. What is this current, sir? 5 amperes. We started with 5 amperes. Again, we got the same 5 amperes back. Our current distribution is 100% correct. Clear? Next, here tell me how many unknowns are there? Single unknown. How many equations required? One equation. How many equations we can write? We can also write only one equation. Why? Because though we have 3 meshes here, I can't write KVL in this mesh. I can't write KVL in this mesh. Reason? I don't know what is voltage across current source. Here also I don't know what is voltage across. Come on, engineers. Current source. Can I write KVL in this mesh? Yes, dears. Okay. So can you tell me what is current in this direction? I minus 5. I minus 5. Let us write KVL like this. Come on, sir. What we write? What write? Let me take this upwards. Yeah. Here I am writing this 8I minus 40 equals to. So here, brother, I am writing here voltage. Okay. We are habituated, right? Started positive, go negative equation. Right. That's why. Once the current is entering like this. I think, sorry, dears. Yeah. This is not required for us, for me. Let me erase this. Let me erase this current here. This one, even this direction of travel. I don't draw, sir. Fine. Can you tell me what is this voltage? Current is entering like this, plus minus. 8 5s, 40 minus 8I equals to, started positive, go negative, following KVL sign condition. We write like this, dear. Okay. I'll show you the advantage even. Started positive, go negative. How much? 28I plus 4I minus 40. What is the value of I from this, sir? 32 plus 8. I equals to 2 amperes. The value of I is 2 amperes. Sir, I am interested to calculate even node voltages here, sir. Please calculate node voltages. Okay, sir. Fine. To calculate node voltage, what should be there? Reference point should be there. Come on, sir. I is 2 amperes. Means what is this branch current? 3 amperes. This current is what? 2 amperes. What is current in this direction? I minus 10. 2 minus 10. Downward direction minus 8. Upward direction how much? Plus 8 amperes. Clear? Right. Come on, tell me, sir. If I call this node voltage as VA, if you call this node voltage as some VB, what is VA? Start here, go to ground, following KVL sign convention. The value of VA is what? 24 volts. What is the value of VB, sir? Start here, go to ground, how much? Minus 32 volts. The value of VA is 24 volts. The value of VB is what? Minus 32 volts. So we have solved this problem by mesh analysis. The two with CD method. We calculated all the node voltages even. Done, sir? Now let us go with nodal analysis. Same problem. Let's go with nodal analysis. Some students are asking, sir, please, sir, please, sir. Okay. Take nodal analysis problem as homework. Start with what method? Direct method. Stop after finding what? Branch currents. Branch currents. Okay. You want me to do homework? Okay. One student is asking, sir, please, sir, you only do homework. Okay, dear. For your sake, I am doing homework. I want to confirm my answers with the earlier method. That's why taking the same reference points and the same node voltages. Fine for you? Right. So, VA into what are the conductances connected to node A? 1 by 8 plus 1 by 28. Next, minus VB by 28. What equation should run in your mind when going with the direct method? First equation of KCL. Algebraic sum of currents leaving the principal node equal to 0. Leaving current to 10. Leaving current to 10. Minus 5 equal to 0. Minus 5 comes other side. How much? Plus 5. Okay. Right. Next, one more equation. What is the second equation we can write? Minus VA by 28. Next, VB into conductances connected to node B. How much? 1 by 28 and 1 by 4. 1 by 28 and 1 by 4 equal to algebraic sum of currents leaving the principal node equal to 0. Plus 10 equal to 0. Plus 10 comes other side. Minus 10. Please solve these equations. You will be getting VA value as some 24. VB value as minus 32 ds. Okay? Right. Doing the problem like this. Mesh and nodal. Easy or difficult? Easy or difficult? Huh? Easy only, sir, but not suggestible methods. Source transformation is best for this structure. Now let us do this problem by source transformation. So now please, can I convert this practical current source into practical voltage source? Yes. Similarly here, practical current source cannot convert into practical voltage source? Yes. Let us convert here. Let us draw the structure, putting this here. Hope the screen is stable to you. So this is not required for me. I am erasing this. Yes. Okay. Right. Let us convert this into practical voltage source. 5 amperes into 8 ohm resistance. How much? 40 volts. 40 volts. Series with what? 8 ohms. 8 ohms. Come on. In series with what? 28 ohm resistor. 28 ohm resistor. Come on. We can also convert this into practical voltage source. 4 ohm resistor. Here a 40 volt source. Examiner's interest is to find this current. This is 28 ohm. This is how much? 4 ohms. Tell me what is the value of I. 40 equal to, started positive, go to negative, following KVL sign convention. How much? 8 plus 28. 36. 36 plus 4. 40. 40I minus 40. What is the value of I, sir? 2 amperes. The value of I is 2 amperes. Come on, got the same answer or not? Same answer or not? Yes. Yes. Sir, without drawing this structure, if we can write this equation directly by looking into this circuit, yes, source transformation is best. If you want, if you can answer only by drawing the structure, current distribution method, mesh analysis is best. Please get my points. Got it? Yes. By looking into this circuit, if we can write this equation, yes, source transformation is best. Without drawing this, you have to view this circuit. Yes. No, sir, I can write this equation only after drawing. Yes, I can say for the given structure, please don't waste your time in drawing this structure. Just do the current distribution and get the answers. Fine, sir. Now, one important conclusions here. Sir, from this, can you tell me what is the value of this current? What is the value of this current, sir? 2 amperes. What is the value of this current? 3 amperes. How much current is flowing in the upward direction? 8 amperes. Yes or no? Right. Suppose, so now please, suppose examiner has, the structure is given, examiner has given this current as some I dash is dash. Suppose examiner has given a question like this structure, for this structure I dash is dash. Okay, mistakenly you applied source transformation. You will be getting a circuit like this. Come on, tell me, sir. As I is 2 amperes, what is I dash? I dash is also 2 amperes, na? Source transformation saying this current has 2 amperes, whereas already done this problem by mesh analysis, we got this confirmation as this current has 3 amperes. Tell me, sir, which current is correct? 2 amperes is correct or 3 amperes is correct? Come on. 2 amperes is correct or 3 amperes is correct? 3 amperes is correct. 2 amperes is wrong. What I am saying is, when examiner is asking I dash here, please don't disturb this branch by applying source transformation. That's why I am telling, don't disturb the circuit by using network simplification techniques. You don't have any right to disturb the circuit by using network simplification techniques. Suppose in this branch, examiner has asked what is I double dash is dash. Mistakenly you applied source transformation. You will be getting this circuit. And can you tell me what is this I double dash, sir? This circuit says I double dash has 2 amps. Whether it is I dash or I double dash, any dash, current is 2 amperes. This is what the circuit says. Come on, getting the point, sir. Right. Whereas, but what is the true current in this circuit? 8 amperes in this direction is the true current. This is what the true current means. What is the conclusion here? If examiner asks current in this branch, don't disturb this branch by using source transformation. By using source transformation. So we have to write one beautiful note here, sir. Very important note. Do not disturb the target branch by using network simplification techniques. Do not disturb the target branch by using network simplification techniques like source transformation and star delta. These are about the two network simplification techniques, dear. Source transformation and star delta. In the starting, I have explained if delta is converted to star, yes, you don't get the correct answer. Even here, you should not disturb the target branches like this. Okay? Right. One more important point. If this current is asked, can you apply source transformation here? No. Can you apply source transformation here? Yes. Next. If this current is asked, can you apply source transformation here? No. Can you apply source transformation here? Yes. Green color pen. If this current is asked, can you apply source transformation here? Yes. Can you apply source transformation here? Yes. Clear? Happy? Right. Source transformation is applicable only load point of view, but not what? Source point of view, but not source point of view. Hope you observed in the earlier circuit. My voltage current power at load is 919, whereas 10 volt source is delivering 10 watts. 9 amps or 10 amps source is delivering 90 watts. 90 watts. Okay. These are what few conclusions we have seen. Yes or no? Or let me explain that for just have a look at this. Yes. Let me slide this down. Yes. Tell me please. What is power delivered by this? 10 watts. Power absorbed by this? 1 watt. Power delivered by this? 90 watts. Power absorbed by this? 81 watts. Source transformation is applicable only load point of view, but not what? Yes. Source point of view. And next, one more important point, sir. Can we apply source transformation to dependent sources? Can we apply source transformation to dependent sources? Yes, we can apply source transformation even to dependent sources provided the controlled variable is out of the portion of the network where source transformation is applied. Provided the controlled variable is outside of the portion of the network where source transformation is applied. Clear, dears? So, let me take one circuit and even explain that point. Clearly written in notes, sir. Giving the statement for one more time. Source transformation is applicable even for dependent sources, provided the controlled variable should be outside of the portion of the network where source transformation is applied. Suppose structure given like this. I think already we have solved the structure in our earlier class. Examiner is asking the value of Ix. Now first question. Question here is Ix. Okay, Ix is dash. My first question. Can I apply source transformation here? I can't apply source transformation here. Reason. My target branch gets disturbed. TGD means not tragedy. My target branch gets disturbed. So I can't apply source transformation here. Next, can you apply source transformation to dependent source? Just now we said, na, source transformation can be applicable to dependent source provided the controlled variable should be out of the portion of the network. See, out of this only, na, out of the portion of the network where source transformation is applied. Fine, yes. Let us apply source transformation here, sir. Come on, tell me. What can be the next circuit here? Let me compress this. Right. 10 volts, 1 ohm, sir. Yes, 10 volts, 1 ohm. Here we have a current source. I think I have not given the current source value. Let us take the current source value as some 2 amperes, dear. Okay. Let me take black color pen. Yeah. Continue, please. What is this, sir? 2 amperes. Okay. 2Ix. What source it is? Current dependent voltage source. You feel like voltage source. Voltage source should be converted into current source. Voltage source should be converted into current source. How shall we do this, sir? Current source means resistance in parallel. Next, here. Here what you get? V by R. V by R. How much? 2Ix amperes. 2Ix amperes. This resistance value how much? 1 ohms. Now tell me, sir, this current in parallel. Parallel currents we can add or not? Yes, we can add. Again, you apply source transformation, sir. Let me slide this left side. Yes, observe, sir. See this, sliding left side. Yes, the structure. Hope the screen is stable to you. Right. Again, you apply source transformation, sir. What you get? 10 volts. 1 ohm. 10 volts, 1 ohm. Here the current value is Ix. Next, let us attach this. Please join these two currents. 2 plus 2x, 4x. Again apply source transformation. What do you get? Resistance in series. You get a voltage source of value plus minus 4 plus 4x. 2 plus 2x. 2 plus 2x. Okay? Right. 2 plus 2x into 1 is 2 plus 2x only, na? Please write KVL, sir. 10 equal to, yes, 2ix plus 2 plus 2ix. 4ix equal to 8. What is the value of ix, sir? 2 amperes. Dear all, yesterday we have solved this problem by mesh and nodal. Hope you remember. We got the same answer. Ix as 2 amperes. Even by using source transformation, we got Ix as 2 amperes. See, sir, source transformation, everyone knows it's a simple topic. See how many points I am giving. It is a network simplification technique which reduces number of nodes present in the circuit and is applicable only for practical sources. Why only for practical sources, sir? Why not for ideal source? So, no, if I take an ideal source whose internal resistance is 0, okay, right. If we want to convert this into current source, V by R we have to do na. Here R value is 0 ohms for us. V by R, V by 0 means, will you take it as infinite ampere current source? Come on, sir, tell me, will you take it as infinite ampere current source? Not possible, na? So, source transformation is not applicable for ideal sources. Ideal voltage source can't be converted into ideal current source. Wrong. Similarly, ideal current source can't be converted into ideal voltage source. Hope you're getting the point, dears. Next, few more points here to update you, dears, regarding the ammeter and voltmeter. Okay, right. Please remember these statements. Complete analysis, proofs and all I do when discussing the measurements for electrical students. Okay, EC students, just remember these statements, important. What is our internal of ideal ammeter? Ideal ammeter, or sometimes you also, some textbooks or some examiners also write this as ideal current meter. Both are same. Ideal ammeter, ideal current meter. Yes. What is this internal resistance? 0 ohms. So, ammeter should be connected in series to the circuit. Why in series to the circuit? Why not in parallel to the circuit? Reason, students used to say different regions, but the technical term is to reduce loading effects. To reduce loading effects. Okay, right. Reduce loading effect means simply we can understand like to reduce the disturbance. Okay, right. Next, what is our internal of? What is our internal of? Practical ammeter. Very low value. Very low value. Okay. Yes. Value not required for us. If examiner's interest is something to calculate with this internal resistance, exam will give that value. Okay. Right. Next. What is our internal of? What is our internal of? Ideal voltmeter. Infinity ohms. Okay. Right. What is our internal of? What is our internal of? Practical voltmeter. Very high value. Very high value. Sir, I want to link this with networks. How I link? Suno please. What is our internal of? Ideal current source. Already discussed. Infinity ohms. What is our internal of? Practical current source. Very high value. What is our internal of? Ideal voltage source. 0 ohms. What is our internal of? Practical voltage source. Very low value. 8 objective questions are there on the board, which will be useful for your competitive exams. Have a look, please. Done? Right. So, regarding the voltage source, current source and all, we know, sir. But, why I am introducing the words meters here? So, now please. What is our internal of ideal meter? Ideal ammeter or ideal current meter? Current meter, sir. Okay. Please don't get confused current meter with current source. Current meter, ideal resistance, 0. Current source, ideal resistance, how much? Infinity. current to meter 0, current to source infinity. Ideal volt to meter infinity, volt to meter infinity, voltage source 0. Please understand this. Right. Further conclusions here. Here 0 ohms, na? Ideal current meter 0 ohms. Okay. If ideal current meter, how much? 0 ohms. Ideal current meter is given on a paper. Simply replace with short circuit wire and do the analysis. Easy students, please understand this. Any question given like ideal current meter, okay, replace ideal current meter with a short circuit and do the problem. That's it, over. Next, easy students, ideal voltmeter is given. Ideal voltmeter is given. How much? Infinity ohms. But how we have to analyze this? Infinity ohms means open circuit. This is do the analysis. Problem is over. Okay, open circuit, do the analysis, problem is over. Next, few more important points. If anyone asks you in a circuit by connecting an ammeter and by using the word ideal ammeter, if anyone asks you what is voltage across, ideal ammeter, ideal current meter. To confuse you, they use the word ideal current meter only, sir. Okay, you may let me use ideal current meter. Yeah, let me erase this. Ideal current meter. Come on, sir. What is voltage across ideal current meter? 0 volts. Sir, how it is 0 volts, sir? Okay, let us calculate what is that voltage. V equal to I into resistance of the meter. Hope it is visible to you, sir. Logo is there. Yeah. V equals to I into Rm. Okay. What is internal resistance of the meter, sir? 0 ohms, na? R internal of ideal ammeter 0. How much? 0 volts. Voltage across ideal current meter 0 volts. Next. Here, observe carefully, please. Current through ideal voltmeter. Current through ideal voltmeter. What is current formula? I equal to V by R. What is internal resistance of voltmeter? How much? Infinity ohms. V by infinity how much? 0 amps. 0 amps. What is current through ideal voltmeter, sir? 0 amperes. What is voltage across ideal ammeter, sir? 0 volts. Getting the point, please. Next. Means what you are using here? Ohm's law. We are using Ohm's law for finding voltage of a current meter. We are using, excuse me, we are using Ohm's law for finding current through voltmeter. Next, so important, right? All these statements clearly written in notes here. Don't worry, right? Right, no need to even note, sir. Just remember, such a competitive exams, what you have to do is you have to concentrate in my teaching. You have to concentrate in lectures. Okay, notes part, yes, I have taken care. So here, please, one more important point I'm telling. Voltage across ideal current meter is 0 volts. Now, if I ask you, voltage across ideal current source. Voltage across ideal current source. Yes, what is voltage across ideal current source? A number of problems we have done. It is not known, sir. It is not 0. 0 is wrong. Looking into this, students used to say this as 0 is wrong. Voltage across current source we have to calculate only by using KVL. This statement I have clearly given in notes, even explained. Okay, right. Voltage across ideal current meter 0. Voltage across ideal current source not known, not 0. Not 0, not known, we have to calculate only by using KVL. Not 0, not known, calculate only by using what, sir? KVL. Okay. Similarly here, please. Similarly here. Similarly, what is current through ideal voltage source? Student think ideal voltage source as ideal voltmeter, they want to give as 0. First 0 amps is wrong. Okay, na? Right. We calculate this only by using what, sir? KCL. Clearly discussed when discussing verifying power law concepts. You have proved from the above 4 problems current through ideal voltage source can be calculated only by using KCL. Similarly, from our 4 problems, voltage across current source can be calculated only by using KVL. I have clearly given these statements, dear. Okay, easy students, be careful. When you are seeing ideal ammeter, ideal current ammeter, replace with short. Ideal voltmeter, replace with open. Triple students, be careful. When voltage across ideal current source is asked, don't say 0 by considering ideal current ammeter voltage as 0. Okay. Similarly, electrical students, please don't write current through ideal voltage source as 0 by considering ideal voltmeter. Done, dears? Let us go with a few more problems. Yeah, let us go with few more problems. Yes, this page. So, till now, source transformation is over, sir, completely over. Dependent source also we have discussed. Please cross check Ix as 2 amperes, which we got in the earlier class. Let us go with some previous gate questions, dear. Previous gate questions, very important. PGQs, previous gate questions. Question number 1. Yes, students, you should answer without putting pencil. Enough practice we have already done. Enough practice is already done, yes. You have to give the answer without putting pen on the paper. What is the value of I? Where that I is, sir? Yes. Here we have this I. Plus, minus, 12 volts, 2 ohms. 2 ohms here, 2 amperes. Examiner's interest is to get the values of I and EDS. Okay? Right. Yes, everything is given. Let me copy this circuit to explain this problem by nodal. Previous question 1, sir. Please give the answer of I. 30 seconds. I will give only 30 seconds. 30 seconds. Over. What is the value of I? Yes. Some students are saying, sir, I value as 4 amperes. Yes. I value as 4 amperes. Perfectly wrong. Okay. Right. I is not 4 amperes. Some will say, sir, I value as 8 amperes. Yes. Wrong. Some are saying, sir, I value as minus 8 amperes. Correct. Huh? Wrong? Huh? No. Correct. Some students are saying, sir, please explain. Okay. Right, sir. But not required, dear. Okay. Right. Please observe. Source current we calculate only by using what? KCL. Okay. We have to get this branch current by KCL. Means this current and this current is required for us. This 2 amperes is coming like this. Yes. Then how to get this current? Since we are getting this current by KCL, I can't get this current by KCL. I can't get this current by current division. Why? Because not a parallel circuit. Only one Bhagavan. Ohm's law. To get this branch current by Ohm's law, voltage is required, distance value is required. Given, nah? Clearly given over there. Come on, tell me. How much current flows here? 12 by 2. 6 amperes flow. 6 amperes flows in upward direction or downward direction? 6 amperes flows in upward direction or downward direction. That is very, very important, sir. Ohm's law, I equal to V by R, V equal to IR, everyone will do, sir. But V equal to plus I into R or minus I into R, or I equal to V by R or minus V by R, KVL sign convention, which you have learned, will give the kind of clarity for us. Done? Please tell me, how much current flow? 6 amperes in what direction? Upward direction. Why upward direction? Why not downward direction? Brother, sign convention of power as well as our KVL sign convention will help you. But I suggest you to follow KVL, to follow sign convention of power. KVL sign convention also we can follow, but it takes a bit time. Sign convention of power easily, sir. Resistor absorbs energy. Resistor always absorbs power. Any element in this universe absorbing power means current should enter what terminal, sir? Current should enter positive terminal. If you are writing this current is flowing in downward direction, 6 amps entering at negative terminal means that element is delivering power. Can resistor deliver power? Not possible. Resistor can never deliver power. Clear, dears? Finally tell me please. 6 amperes. Huh? Yes. Here, if you want to note, any student you want to note, please note, sir. What point you have to note? By Ohm's law, 6 amperes. 6 amperes by Ohm's law. This direction is because of sign convention of power. Resistor is absorbing power. Okay. 6 amps coming like this, dear. Okay, 6 amperes coming like this. How much current flows here? 8 amperes will flow here. Now tell me, what is the value of I? Minus 8 amperes. The value of I is minus 8 amperes. What is the value of E, sir? Started positive, go to negative, following KVL sign condition. How much? Minus 60. Okay, let me give this resistance value, sir. Even this resistance value is 2 ohms. Okay, right. So, value of E, started positive, go to negative, minus 16, minus 12. I can't go like this way because I don't know what is voltage across current source. Minus 16, minus 12. How much? Minus 28 volts. Pen not required, yes. Pen not required. Just by looking at the circuit, we can answer. Same problem, let us go with nodal analysis. Before going nodal analysis, yes, if you want to verify power law for this structure, yes, you can also verify, provided if you know what is voltage across this current source. What is voltage across this current source? Started positive, go to negative. What is voltage? Yes, please. 4 minus 12. 4 minus 12, what is this voltage? Minus 8 volts, which clearly indicates what? Assumed polarities are wrong. Reverse polarities are correct. Means here plus, here minus, how much? 8 volts. Assumed polarities are wrong. Reverse polarities are correct. Getting the point? Yes. Right. So current is entering at positive terminal. This element delivering power or absorbing power? Absorbing power. Anyhow, this element absorbs power. Anyhow, this element absorbs power. Anyhow, this element absorbs power. Lastly, coming to the source, has to deliver power. No other option. Okay. Right. E value we got minus 28, na? Means with this polarities, it is plus 28 volts. How much current is entering, ma? 8 amperes is entering. This source is delivering power, remaining all the elements absorbing power. Verify power law, homework, dear. Homework, hostel work, room work. Okay, right. Please do this. Done. Now, same problem. Let us go with nodal. Nodal, what reference point used to take? Any reference point, sir. Let us take this as the reference point. Now, what is this node voltage? 12 volts. Let us apply KCL over here. What is this current? 6 amps. What is this current? 2 amps. What is this potential? 0 volts. What is this potential? Start here, go to ground. Let me take the resistance value, yes, 2 ohms first. Okay. Right. Come on, tell me. What is this potential? Start here, go to ground. How much? E plus 12. This potential is E plus 12. Please apply KCL here. What you get? Sigma leaving equals 0. Kareto. What you will get is 6 plus 2 plus E plus 12 minus 0 by 2. E plus 12 minus 0 by 2 equal to 0. Get the value of E. Get the value of E. Over. Clear? Shall we go with next question? Next previous gate question, sir. One more question. Right. Even this is an important question, dears. Okay. Right. Let me draw the structure here. The value of E, 1 volt, 1 ohm. Examiner's interest is to get the value of Vx for this circuit. Sir, where is that Vx? Here is this Vx. Plus minus Vx, 1 ohm, plus minus 1 volt, 1 ohm. This resistance is R ohms. This is the value of E. This is 6 amperes. 6 amperes. So I want to do this problem by mesh and nodal. Let me copy this circuit. Copy. Yeah. Whereas in offline classes, dear, same structure I want to see. On the same structure I used to do mesh and nodal. Okay, I will show you how I do in offline class for you. Okay, right. So, now dears, what is the value of Vx? Data is perfect. Yeah. What is the value of Vx? First, students used to think like, sir, 1 ampere is coming in this direction. Wrong point. Why? Come on, tell me. Apply Ohm's law. Give the value of current. But 1 amp is flowing right side or left side? 1 amp is flowing left side. Why? Resistor is a energy dissipating element. Okay, na? Right. So, here 1 ampere flows like this. 1 ampere flows like this. Come on, sir. 1 ampere coming like this. What is this current? 1 ampere. What is this current? 1 ampere. How much current coming like this? 6 amperes. 6 amps coming like this, 1 ampere going like this. How much current coming like this? 5 ampere. What is Vx? Started positive, go to negative, following KVL sign convention. Direction of all branch current, opposite. What is Vx? Minus 5 volts. Over problem. Minus 5 volts. Everything lies where, sir? Everything lies in the putting this current in this direction. If students put 1 amp in this direction, okay, 1 amp comes like this, 6 amps comes like this, 7 amps goes like this, minus 7 volts, readily available in options. Readily available in options. Okay, right. So if you want to proceed further, let us take R value as some 2 ohms. Okay, na? Right. So calculate the value of E. E is question mark. Verify power law. Huh? Please, sir. Homework. Okay. Learn, just listen class here. Just listen my class. Follow CRQs. You will get the subject. Okay, dears? Right. Next Q, please. Yes, as said, I want to do nodal on the same structure, right? Okay. How I used to do nodal on the same structure? On this structure itself, in the class, offline class, I used to take this as reference point and this as Vx here. Okay. Apply KCL at this point. Why? Because I know this current now. How much? Vx. This current I know how much? 1 amp. This current I know how much? 6 amps. By KCL, entering equals leaving. How much? Entering current 1 amp equal to leaving current Vx plus X. What is Vx? Minus 5 amperes. Which is also equal, if you want voltage, Vx equal to minus 5 into 1. How much? Minus 5 volts. I used to make circuit clumsy. It appears clumsy in the offline class. Reason? We'll be drawing the structure for one time. On same structure I used to do measured nodal. Whereas in online, I can copy the structure instantly. Okay? Right here. This is what some few advantages we are feeling as a faculties we are feeling with an online class with a digital board. Done? Right. Next, here this is over, sir. Now let us go with one more structure. Let me draw the structure, find the value of Vx. Even in this question, we have to find the value of Vx. Very important discussion. Node voltage, resistance values given here. Examiner interest is to calculate this node voltage. Even here, examiner has given one more current source. Current source value 2 amperes in this direction, 1 ampere. These resistance values 1 ohm and 1 ohm. Come on, engineers. How shall we do this? Vx is dash. 30 seconds time. Vx is dash. Yes. Getting the answer? Vx how much? Plus 5 volts. Minus 5. Minus 2. 0. Okay, different answers. Huh? Right. Okay, sir. Observe carefully, please. Let me put this circuit here. Yes. So students used to think like this. Node voltage. Node voltage means use our diamond statement. Start at that point, go to ground following KVL, sign convention. Yeah. So to go, I can't go like this. Why? Please take the path in which you know the voltages. I don't know voltage across current source. I don't know voltage across current source. I require voltage here. I require voltage here. How to get this voltage? This voltage. Voltage across resistor can be calculated by using Ohm's law. Okay, means we require current over there. So let us start getting current. Students used to think this 2 amp will go into ground like this. No, 2 amp won't go into ground. At every node, KCL has to be satisfied. Yes or no? Yes, 2 amps coming like this. Current here, 2 amperes. Next, sir, how much current should come like this? That splits like 1 amp and 2 amps, sir. 3 amperes. What is this current? 1 ampere. What is this current? 2 amperes. Both adds like what? 3 amperes. So now I can also explain you like this. This current, this is 3 amperes now. Happy with this? Satisfied with this? This is 3 amperes. Okay. 1 amp coming like this. How much current should come like this so 3 amps will flow here? 2 amperes now. Here 2 amps means here it should be 2 amps now. How this current can be 2 amps? From this source only now. Because of this source only current here 2 amperes now. Means what is the conclusion here? What is current in the ground? 0 amperes. Okay? Right, dears. What is Vx? Start at this point, go to ground following KVL, sign convention. Start here, go to ground following KVL, sign convention. Direction of neutral, branch current opposite. Direction of neutral, branch current is opposite. What is Vx value, sir? Minus 3, minus 2. What is the answer? Minus 5 volts. Minus 5 volts. Now, interesting question here. What is really this Vx? What is this Vx, sir? Sir, in my earlier class, you have given the statements. What is that statement? Node voltage equals to branch voltage if that branch is connected to ground. Node voltage equals to branch voltage if that branch is connected to ground. So, sir, what you are saying finally? This voltage is nothing but voltage across current source. Yes, dear. Sir, prove it. Okay, one more time I will prove. Please assume voltage across these 2 amps as some Vy. Okay. Now, what is Vx? Start here, go to ground following KVL sign convention. What is Vx, sir? Vx is nothing but what? Vy. Means with this polarity is, what is voltage, sir? Minus 5 volts. Now with this polarity is 5 volts means reverse the polarities. Here it is plus, here it is minus. What is this? 5 volts. Now current is entering at negative terminal. This element is delivering power. Please sir, okay. Let us take power law homework. Get the point, please. Right, sir? Homework question. Next give. Let us draw one more structure. Resistor here, voltage source, resistor connected to a current source. Right. Right, sir. Okay. Fine. What is this value? VAB or this value, sometimes it is written like this. Yeah. What is VAB? VAB is dash. It's a 4 volt source, 2 ohm resistance, R ohms, 2 ohms, and let me remove this current source. We'll put later. What is VAB? Come on. What is VAB? Even this is previous gate question, sir. Okay, I'm doing all the previous gate questions. Question number 4, I think. Question number 4. Yeah. Some current I comes like this. Open circuit here. No current flows here. 0 amperes. The same current I comes like this. Okay. So here 4 equals to started positive, go to negative following KVL sign convention. 2I plus 2I, 4I. What is the value of I, dears? Come on, engineers. 1 ampere. Once I is 1 ampere, what is VAB? Started A, go to B following KVL sign convention. Go like this, you get the same answer. Or started A, go to B following KVL sign convention, you get the same answer. If you are going like this, VAB, how much? Minus 2 plus 4, 2 volts. 2 volts. What is VAB? Go like this. Started A, go to B, how much? 2 volts. Whether you go in clockwise direction or anti-clockwise direction, you get same VAB as 2 volts. Okay? Right. So, this is how we do the problem. Next, I told you similar question. Let me take one more current source here. A bit faster, sir. Faster. Answer, please. Resistance, open circuited. Here I am putting one more resistance. I am putting a current source. And I am asking for the value of VABDS. How shall we do this? 2 amperes, 2 ohm, here R ohms, here 2 ohms and 2 volts. Or let me take 4 volts. Any value, no problem, sir. Any value, no problem. What is VAB? Yes, VAB is dash. How shall we do this? Come on. Started A, go to B following KVL sign convention. Can I go like this? No. Reason, I don't know what is voltage across what? This current source. I don't know what is voltage across current source. Now tell me, what is this current? 0 amperes. What is this current? 2 amperes. Any value of resistance connected, current is 2 amperes, sir. Okay. Here what is the current? 2 amperes. Here what is the current? 2 amperes. Current distribution is perfectly over. Now I can go like this. Yes. Tell me, sir, what is VAB? Here it is 0 volts. So 0 plus directional branch current. Same is what? Plus 4. Next, directional entering what polarity? Positive polarity. Plus 4. How much? 8 volts. Problem is over. 8 volts. Done. Easy or difficult? Easy or difficult? Network subject. That is it, yes. Next question. Next question. This is what one structure. Previous gate question, DS. Gate or some competitive exam question. What is the different voltages? All are connected in series. Different voltages. 1, 2, 3, 4. Right. Here 1 volt, 1 ohm, 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 2 volts, 3 volts, 4 volts, A, B, C, and D. Let us find all the voltages. VAB, okay. VAB is dash, VAC dash, VAD dash, VBA, VBD, all are dash. Come, what are the combinations that are possible? Let us do all the combinations. Huh? Right, yes. How shall we do this? Say some current I flows in circuit. Since it is a single equivalent mesh, say some I flows, even in this branch the current is I, even in this branch the current is I, even in this branch the current is I. Come on, tell me how much current flows in circuit. Let us write the KVL equation. 1 equals to started positive, go to negative following KVL sign convention. 1 equals to, since all the resistances are in series, how much? 2i plus 2i plus 2i plus 2i. How much? 8i plus 2 plus 3 minus 4. What is the value of I? 0 amperes. What is the value of I, sir? 0 amperes. So what is VAB now? Started A, go to B, how much? 2 volts. What is VAC? Started A, go to C, how much? 2 plus 3, 5 volts. Excuse me. What is VAD? Started A, go to D, how much, sir? 1 volt. 1 volt. Okay. Go to the point. What is VBC? 3 volts. What is VBD? 3 minus 4 minus 1 volt. Any combination you can do, sir. Any combination easily can do. Next, what is the other way that we can do this problem? Some students used to ask me, sir, can we do this problem by nodal, by taking any reference point? Yes, you can take any reference point. So let us take this as reference point. Let us write this node voltage as VA, node voltage as VB. Let us write this node voltage as VD. Okay. Please write KCL here. Please write KCL here. Please write KCL here. Write the KCL equations and solve the equations. How you will be writing the equations? You can feel like this. See, you can feel these two resistance are in series. Nah? You can feel like a single resistance. 2 ohm resistance. That is one point. Whether this voltage source you put this side or that side, your wish, sir. So if we consider this as a 2 ohm resistance, for me, this node potential is VA. What is this node potential? 2 plus VB, na? 2 plus VB, this node voltage. Next, similarly here, if you consider this as a 2 ohm resistance, what is this node voltage? VA. What is this node voltage? Start here, go to how much? 1 plus VD, na? Like that, you please try the problem, do the problem on your own and get the values of VA, VB, VD, and what is VAB, sir? VA minus VB. For sure, you should get 2 volts. What is VAC, sir? VA minus VC. For sure, you should get 5 volts. What is VAD, sir? VA minus VD. For sure, you should get 1 volt. For sure, you should get 1 volt. Clear? Let's go to next problem. Next problem, sir. One more important problem, important structure, I can say. Plus minus 1 volt. Important discussion we can do here, dears. Even this is resistance, all are 1 volt, 1 ohm, 1 ohm, 1 ohm. This is previous competitive exam question. Plus minus 1 volt. Yeah. 1 volt, 1 volt, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Examiner's interest is to get this value. Sir, I wish to do some analysis on this. Let me copy this. Copy for 1 time, 2 times, if possible 3 times. Huh? Right. Complete analysis. Very important, yes. Very important. Examiner's interest is to get the value of I. Let us do this problem both by mesh and nodal analysis. Interesting aspects we can analyze. Okay. Right. Even I want to give an important point here. Mesh analysis. Let us go with what method? Start with what method? Stop after finding what? Start with what method? Stop after finding what? That is important. Okay, right. Come on, sir. Which method shall we follow? Which method shall we follow? We don't have any current sources here to go with the CD method. And only one option we can have is either we can go with the direct method is one option, and finding node voltages. Direct method is one option and we can go with the node voltages. That's it, na? Yes or no? Yes. So we can write the equation, sir. What equation we can write? Mesh 1 equation. I am writing DS. Total resistance in mesh 1. I1. Resistance common between mesh 1 mesh 2. I2 provided. If you consider this as mesh 1, this as mesh 2, this as mesh 3 currents. I1 currents. I2 currents. I3. Okay. Right. I1 minus I2 plus 0 I3 equals to, please run first equation of KVL in your mind. Direction not all integrate minus. Minus comes other side, what sir? Plus 1. Coming to second mesh. Resistance common between mesh 2, mesh 1. How much? Minus I1. Total resistance in mesh 2. 4 I2. Mesh 2, mesh 3. Sorry, 0. 1 na? 1 is there here. Yeah, minus. Minus 1 I3 equal to 0. Please understand carefully, sir. Mesh 2, mesh 1 resistance. Minus 1. Total resistance in mesh 2. 4 ohms. Mesh 2, mesh 3. Minus 1. Okay. Equals to, no source is there, 0. Next. Yes. Mesh 3, sir. Mesh 3, mesh 1, 0. 0 I1. Mesh 3, mesh 2, minus I2. Total resistance in mesh 3, plus I3. Equal to direction total entering at plus 1. Plus 1 comes other side, minus 1. So, let me open the calculator. Substitute the values here, dear. On 5. Equation 5 and 2. Okay. Let me substitute coefficients here. 1. Come on. I2. Minus 1. 0. Plus 1. Next. Second case. Minus 1. 4. Minus 1. 0. Next case. 0. Minus 1. 1. Minus 1. So here we are getting I1 value as 1 ampere, sir. Let me note the values here. I1 value as 1 ampere. Yes. Okay, I think the pen has selected. Black pen. Yeah. What is this current, sir? 1 ampere. Next. What is I2 current, sir? 0 amperes. Here this current is 0 amperes. Next. Even I3 current, we got this current as minus 1 amperes. In this direction, minus 1 amperes means, in this direction, minus 1 amperes means, I can put in this direction, plus 1 amperes. Okay? Right. Let us do some analysis here, dears. Okay? The analysis which I do from now is important for me. Sir, in this direction, minus 1 means in this direction, plus 1 only, na? So, can I erase this minus 1 amperes? Okay. Right? I want to do some analysis here. That's the reason, huh? Okay. So, here 1 ampere is coming, 0 amperes is flowing. Here 1 ampere is coming, 0 amperes is flowing. Okay? Right. And, sir, can you tell me what is this current now finally, sir? 0 amperes. This current is 0 amperes. I well, we got 0, na? Right. Sir, one important point I wish to give here. What is this branch? Separate branch or common branch? Separate branch. What is this branch? Separate branch or common branch? Separate branch. Separate branch. Branch current equals to mesh current. Separate branch. Branch current equal to mesh current. Means what I want to say here is, if this mesh current is known, this current can be written, this current can be written. Or if this current is known, this current can be written, and this current can be written. Or if this current is known, this and this can be written. By using what statement? For separate branches. Branch current equal to mesh current. Mesh current equal to branch current. That's it. Separate branch, branch current equal to mesh current. If mesh current is given, branch currents can be written. If branch currents are given, mesh current can be written for the analysis purpose. Clear, dears? Right. So here, what is the further analysis, please? 1 ampere coming like this, 0 ampere going like this. Means what is this current, sir? 1 ampere. 1 ampere coming like this, 0 ampere coming like this. What is this current, sir? 1 ampere. Means, next, 1 ampere coming like this, 0 coming like this. What is this current? 1 ampere. 1 coming like this, 0 going like this. What is this current? 1 ampere. Means whatever the Suno here, very, very important point. Power absorbed by this resistor, 0 watts. Power absorbed by this resistor, 0 watts. Power delivered by the source, 1 watt. Power delivered by the source, 1 watt. Whatever the power that is delivered by the source, that is absorbed by this resistor. Whatever the power that is delivered by the source, perfectly absorbed by this resistor. Having any doubt, cross check. I square into 1 watt. I square into 1 watt. Clear? Right. Next. So finally, by using direct method, we got these answers. Clear, please? Clear, dears? Right. And even some will say, sir, let me use green color pen. Sir, here voltage is 1 volt. Yes, dear. Who said no? Even here voltage is 1 volt. Sir, who said no, ma? Who said no? Okay? Right, dears. So this is how we can do the problem. Or some students will say like this. Let me use a pink color pen. Just only one equation. As pink color is not that much visible. If this current is I, what is this current, sir? I. If this current is I, this current is I. By what statement? For separate branches, branch current is same as mesh current. They will apply KVL for the outermost closed path like this. 1 equals to, okay, 1 into I plus 1 plus 1 into I. I value they will be getting as 0 amperes. Find here who said no. Who said no? You can also do like this. I is over. I value we got as 1 ampere. Next. So with the green color pen, okay, let me find the node voltages. Sir, I am taking this as the reference point. What is this node voltage? Start here, go to ground. How much? 1 volt. What is this node voltage? 0 amperes into 1 ohm resistance, 0 volts. What is this node voltage? Start here, go to ground. How much? 1 volt plus 0. Why I am putting plus 0? I have a reason. How? Why? This is up to here 1. From here to here 0. Totally how much? 1 volt. Okay. Perfectly done this problem by mesh analysis, sir. We have done this problem by DM method. Calculate up to node voltages. Even verified power law. Power law also I have verified for you. Yes. Perfect. Over. Now the same problem let us do by nodal analysis. That is the interesting scenario here. Right. Let us do this problem by nodal analysis. Blue color pen. Let me slide the board left side. Okay. Okay, sir. Sir, before going to nodal analysis further, can I write the currents which we got in the earlier circuit? Yeah. Come on, tell me. What is this current we got, sir? 1 ampere. What is this current we got? 0 amperes. What is this current, sir? 0 amperes. What is this current, sir? 1 ampere. That is fine for us. I have taken this as reference point. Suppose if I take this as the reference point. Come on. What is this node voltage? 1 volt. What is this node voltage? 0 volts. What is this node voltage, sir? Start here, go to how much? 1. Go come like this. 1 minus 0. 1 minus 0. How much? 1 volt. Getting the point, please? Next. Suppose if I take this as a reference point. If I take this as a reference, okay, let me take one more structure as we have structures. Let me copy for one more time. Yeah, copy, copy. Okay, right. Let me put the structure here. Let me take this as a reference point. This as the reference point. Before calculating node voltage, please tell me how much current we got here? 1 ampere. How much current we got here? 1 ampere. What is this current? 0 amperes. What is this current? 0 amperes. Let me take green color pen and find the node voltages. Tell me, sir, what is this node voltage? Start here, go to ground. How much? Minus 1 volt. What is this voltage? Start here, go to ground. How much? 0 volts. What is this voltage? Start here, go to ground. How much? Minus 0, minus 1. I repeat. Go like this. How much? Minus 1. Minus 1 plus 0. If you go like this, minus 1 plus 0. Minus 1 plus 0. How much? Minus 1 volt. Clear, DS? So, these are what the node voltages we have calculated by using different reference point. And the analysis we have done is mesh analysis. Now, let's go with what? Nodal analysis. Come on, yes. Let's go with nodal analysis, exclusively nodal analysis. How we'll be doing the problem. Okay. Right. Sir, first we have taken this as the reference point. Let us get the node voltages and cross-check our answers with that method. Okay. So, assigning what is this node voltage? What is this node voltage? Nodal analysis. Start with what method? Stop after finding what? I start with the VD method. I stop after calculating branch currents. If you can cross-check the same structure done by different competitors, different faculties, they have done with a regular method of nodal VA, VB, VC. They have taken some 3 node voltages and done the problem. Here we can do the problem in single step DS. Okay. Right. How we can do in single step? Yes, wait. Shyam sir will explain. Shyam sir is there. So this node voltage, come on sir. VD method means writing the unknown node voltage in terms of what? Known values. Yes or no? Start here, go to ground. How much? 1 volt. Next. Many want write even this node voltage as 1 volt, which is a blunder. Why? What statement we are using? Third statement of KVL. Start here, go to ground following KVL sign convention. How much? 1 volt. Plus, we don't know this one. Nah? We don't know this voltage not. Yes. Okay. Many will be thinking, start here, go to ground. Start here, go to ground. They will come up to this and they will write this as 1 volt. But if you observe, you go like this. Yes, I into 1 is this voltage. So first let us write this node voltage, sir. What is node voltage? Start here, go to ground. How much? I volts. I volts. Okay. What is this voltage, sir? Start here, go to ground. How much? 1 plus I volts. 1 plus I is your answer. In single step, you will be getting the answer, dear. Sir, how in single step? Yes, if you observe, I can't write KCL here. Why? We know this current, we know this current. We don't know this current. Super node. We can't write here. This current, we know, this current, we know. We can't write this current. So, by Gaussian surface or cut the network like this. Cut the network. Touching here, touching here. We know this current, we know this current. Apply KCL. Or, cut the network like this. We know this current, we know this current. Apply KCL. Come on, sir. Apply KCL here. Leaving equal to 0. Sigma leaving equal to 0. What is leaving current in this direction? 1 plus I minus 1 by 1. What is this leaving current? Come on. What is leaving current, sir? I equal to 0. Over. Problem over, sir. Single step. What is this potential, sir? 1 plus I minus 1 by 1. What is the current here? I. Come on. Can you solve this? 1 gets cancelled. 2I equal to 0. What is the value of I, sir? 0 amperes. The value of I is 0 amperes. Got the same, na? I value we got as 0 amps, na? Right. Once I is 0 amps, come on, tell me. What is this voltage here? 0 volts. What is this voltage? 1 volt. What is voltage? 1 volt. Perfectly matched, yes. Perfectly matched. Okay. Here, writing this equation is important. Writing KCL equation for the Gaussian surface. This is important, sir. This equation, what a beautiful equation. Sir, you want to write KCL equation here? Okay, right. What is the leaving current? Let us go with the definition. Sigma leaving equal to 0 here. Come on, tell me. What is leaving current? Minus I. What is leaving current? 1 minus I by 1 equal to 0. What is I? 0 only, na? From here, what is I? 0 amperes or 0 volts. 0 amperes or 0 volts. Okay? Clear, dears? You want some homework? Sir, please, give some homework. Okay. I want to give some homework, dear. What is that homework? Let us replace this with 2 volts and do the problem. Let us replace this with 2 volts and do the problem. 2 volts and do the problem. Okay? Right. And even I want to give one more work for you. Verify power law. Till verify power law, do the problem. Do the problem both by mesh and nodal, sir. Mesh means what equation should come into your mind? KVL, Ohm's law. Nodal means, come on, KCL, Ohm's law should come into your mind. Clear, dears? Next, see, I want to modify the structure like this. How I want to modify in the sense, right. Let me erase this 1 ohm resistance here. Let me erase this 1 ohm resistance here. Similarly, let me erase this 1 ohm resistance here. Okay, right. And let me connect that resistance here to the problem. Let me slide this right side. Let me connect that resistance here and do the problem. Connect the resistance and do the problem. Resistance values 1 ohms. 1 ohms. Is there any change, sir? Is there any change? Okay. Will you do this problem? Please do this problem. Verify power law. Verify power law homework and comment in the Telegram group. Everyone should do this. Yes. Everyone should do this problem and comment in the Telegram group. Okay. Right. Also, not only 1 ohm, not only 1 volt here. Also put 2 volts and do the problem. Put 1 volt, do the problem. Put 2 volts and do the problem. Verify power law, dears. Done. Right. Next question. Let's go with next question. Very important question, dear. Given in GATE 2012 for 2 marks. GATE 2012 question for 2 marks. Okay. Right. GATE 2012 2 marks. Come on. You should answer. It's a 2 marks question, or we can answer in less than 5 seconds. Okay. How we can answer less than 5 seconds? Beautiful question, dears. Resistor, all the resistance values given as R. All the resistance values given as R. But few resistances, he has given some values. Even this resistance value is R. And he is asking for the value of VCD. Sir, where is that VCD? Just a second, yes. Just a second. Let me draw the circuit. 20 volts. Okay. R ohms. R. Even here. R. This one. 5 volts. Okay. Here this resistance value given as even R. This is given as some 6 ohms. Not some 6 ohms here. 3 ohms. Okay. Even 6 ohms also we can take, no problem. Right. This is given A. This is given B. And here this is given as a current source. Here current source is given. Yes. This is given as some 1 ohm. This is given as 2 amperes. This point is represented C. This point is represented D. Beautiful question. If VAB is 6 volts, VCD is dash. If VAB is 6 volts, VCD is dash. Come on, sir. If VAB is 6 volts, VCD is dash. Question, structure appearing bigger. 2 marks is perfect. But we can answer without putting pen. Pen is not required, yes. Everything is easy if I am teaching. But practice, yes. Practice. Done. Even I have a reason. Okay, right. Questions will be given, sir, and answer solutions will be posted 1 to 2 days later. Practice, work on your own first. Come on, tell me. Look at this problem first. Yes, come on. VAB is given as 6 volts, VCD is dash. Come on, please. Yes, how shall we do? VAB is 6 volts. Means what? A positive, B negative. A positive, B negative, 6 volts. Apply Ohm's law. Tell me how much current flows. 6 by 3. How much? 2 amperes will come in this direction. 2 amperes will come in this direction. Now my question here. This branch current is known. What is this mesh current? Come on, engineers. 2 amperes. 2 amperes. 2 amperes coming like this. In this mesh, 2 amperes coming like this. Come on, tell me. What is this 1 ohm? It is common between this mesh and this mesh. Common branch current is difference of mesh currents. 2 amps coming like this, 2 amps coming like this. Both currents adds like what? 4 amperes. Both currents adds like what, sir? 4 amperes. Now what is VCD? Start at C, go to D, following KVL sign convention. How much? Minus 4 volts. Minus 4 volts. Come on, sir. This current coming like this. This current coming like this. Both currents go like this only, na? Both currents goes like this only, na? Okay? Right. If you want difference of current in sense, 2 amps coming like this. What is current in this direction? Minus 2 amps. Okay. 2 amps coming like this. Minus 2 coming like this. Both are like 4 amps only, na? Clear, dears? Right. And one more point. Even I can also explain you in another way, and I can prove how this current is 4 amperes. Let us go with the Gaussian surface. Draw Gaussian surface here, dear. Touching at how many points? 1. Touching. 2. Touching at 3. Come on, tell me. How much current is entering like this? 2 amps entering. How much current entering? 2 amps entering. 2 amps entering, 2 amps entering. How much current should leave? 4 amps should leave, na? Clear? Perfect. Got it? Okay. Right. So finally 4 amperes goes like this. Or draw Gaussian surface here. Draw Gaussian surface here. Okay. Touching at what point? Here. Touching here. Touching here. How much current leaving? 2 amps. How much current leaving? 2 amps. How much current should enter? 4 amps. Once you know this branch current, started C, go to D, following KVL sign condition minus 4 volts. Correct? Students used to think they want to convert this delta into star. Some students try delta into star. Work for whole day. You don't get the answer. Okay? You have to do like this. Clear, dears? What point is important here? If this current is 2 amperes, writing this mesh current as 2 amps, writing this branch current 4 amps is important. That's why I'm clearly mentioning, keep on making the statement. If branch current is known, mesh current can be easily written. Fine? Right. So here still what modification can be done in the structure? Suppose if examiner give reverse current, if reverse plot is VAB is given as minus 6, then how you do? Means here with this plot is 2 amps is going like this. 2 amps is going like this. This 2 amps is entering like this. Means I can say 2 amps coming like this, 2 amps going like this. 2 amps entering like this, 2 amps going like this. Come on, KCL satisfied or not? Perfectly satisfied. What is VCD now? 0. If VAB is given as minus 6 volts, what is VCD, sir? 0 volts. Why, sir? 2 amps entering, 2 amps going. KCL is satisfied. Here current is 0. Okay. Right. Even I can give one more explanation how I can do this in the sense or what examiner has really thought. Let me compress this. Yeah. Sir, here tell me please, whatever this branch we have, this is a particle current source, na? Can you apply source transformation here? Yes. If you apply source transformation, the circuit will be like this. The CD branch used to be like this. What is the resistance here? 1 ohm. But here 2 volts. Right side arrow mark. Right side positive polarity. Right side positive polarity. Tell me how much current is flowing, sir? 2 amperes is flowing. Yes, let me slide this. And you tell me please, current is entering at what terminal? Positive terminal. Current is entering at positive terminal. Means this element absorbing power or delivering power? Absorbing power. So how much power is absorbing, sir? How much power is absorbing? 4? Huh? V into Y, sir. 4 watts of power it is absorbing. Okay? Yes. Source absorbing power means actually it is a resistor. From substitution theorem concept, examiner modified like a voltage source. R equal to what? 1 ohm resistance here. 1 ohm resistance. See, can I put like this? 1 ohm resistance and 1 more 1 ohm resistance, but current flowing is 2 amperes. Voltage drop here is 2 volts. Can represent like this. Come on, sir. Further, what can be the next step of this, please? Total resistance. How much? How much? This is C. This is D. Current 2 amperes. This is 2 ohms. What is VCD? Start C go D. Minus 4 volts. Actually, this is the case, sir. If I have a single resistance here, everyone can easily answer. Everybody can easily answer. Why? Because here 2, here this current is 2, obviously minus 4 volts, everyone can answer. See how intelligently examiner has framed the question. This resistance, this 3 ohm resistance, he has drawn like this. Okay, he got this drop, represented like a source. Applied source transformation for this, represented like this. Clear? Next, even I can give other way of explanation, some other way of explanation. What is that? Whatever the 2 amps coming like this, the 2 amps divides into this. Again, all these currents will get added at this node. Again, all the currents get added at this node. But for this 2 amps, 1 more 2 amps is getting added and 4 amps is flowing like this. 2 amps, some portion of current, we don't know. Some portion of 2 amps divide into this, divide into this, divide into this. Again comes to this node. At this node, this current, and this current is adding 2 plus 2, 4 amps is flowing. You can also think like that. Clear, dears? Right. Let us go into the next question. Next question, sir. One more important previous gate question. Yes, some analysis we can do here. 1 amperes, 1 ohm, and given here a 1 volt source. Right, and even this current is 1 ampere. 1 ampere, 1 volt, 1 volt, 1 ohm, 1 amp. Examiner's interest is to get this node voltages V1 and V2. V1 and V2. How shall we do this? Excellent question, sir. See how we will be doing. Right? Yes. V1 and V2. Sir, whenever I see a super node, I can't control myself and I want to go with what method, sir? VD method. In VD method, this V1 can write as start here, go to ground. How much? 1 plus V2. V1 we can write as what? 1 plus V2. That is one equation we can write. Okay? Right. V1 as 1 plus V2. Sir, you want to do this problem one more way? Let me copy this. Yeah. Let me explain. Okay, sir. Fine. Blue pen. 1 plus V2. Now tell me how many unknowns you have. Only single unknown, which is V2. Then how shall we do this problem? Please draw a Gaussian surface like this. Gaussian surface like this. Touching at what points? Touching here, touching here, touching here, and touching here. And but whatever the points it is touching, we know the currents. Let us apply KCL. Entering equals to leaving. How much current entering? 1 amp. How much current entering? 1 amp. Totally 1 plus 1 amp is entering. Leaving current. What is leaving current? This minus 0 by 1. But what is this? V1. But what is V1? 1 plus V2. 1 plus V2 minus 0 by 1. Next. What is potential? V2. What is potential? 0. Finally, this is V2 by 1. V2 minus 0 by 1. Again, I repeat, sir. So now, please. What is this potential, sir? V1. But what is V1? 1 plus V2. V1 minus 0 by 1. V1 minus 0 by 1. But what is V1, sir? 1 plus V2. Yes, tell me, please. Come on. What is this potentials here? 2 equals to V2 by 1 plus V2 by 1. How much? 2 V2. What is V2, sir? 1 volt. What is V2? 1 volt. Correct? Yes. 1. I think somewhere we have gone wrong. Yes. Yeah. Let us erase this calculation part. Some mistake. What is that mistake? 2 equals to 1 plus 2V2. Earlier we have missed this 1. Okay. What is V2? 1 by 2 volts. Once V2 is 1 by 2 volts, can you tell me what is V1? V1, this is 1 by 2. 0.5. 1 plus 1 by 2. How much? 1.5 volts. V1 is 1.5 volt. Sir, can we proceed further and verify Taylor's theorem by writing currents in all the branches perfectly? Yes. What is V1 we got? 1.5. V1 1.5 means what is this current, sir? 1.5 amperes. What is this current? 0.5 amperes. 1 amp coming like this, 0.5 coming like this. What is this current, sir? 0.5 amperes. 1 plus 0.5 goes like 1.5. You tell me, what about this source? It is delivering power. Delivering power of how many watts? How many joules? 0.5 watts. 0.5 watts. Getting the point here? Right. It is delivering a power of 0.5 watts. So you will be getting a voltage here, sir. What is this voltage? 1.5 volts. Even what is this voltage, ma? 1.5 volts. 0.5 volts. What is voltage? 0.5 volts. Please, sir. Please, sir. Okay. Verify power law homework. Done. Next. Sir, you copied this structure for one more time. Reason, sir. Yes, I have reasoned, yes. See, examiner given circuit like this. Okay. But what I want to do is, I want to erase this reference point. Sir, if you erase, wait, yes, wait, what happens? Please wait for some time. Even let us erase this even. Okay, right. Sir, by erasing this reference point, what do you want to do? I want to take this as a reference point. Sir, why you are doing this? Wait, no, nothing happens. You don't get any shock, right? Huh? What is V1 here? Start here, go to how much? 1 volt. This voltage I don't know, sir. Let us consider this node voltage as some Vx. Let us apply KCL here. Sigma leaving equal to 0. Okay, right. This current you know. What is this potential? 1 volt. What is this potential? 0 volts. What is this potential? Vx. What is this potential? Vx. This current you know. Okay, sir. Applying KCL here, dears. Yes, no, please. Applying KCL here. This current you know. This current you know. This current you know. This current. Come on, tell me, please. How shall we write the equation? 1 plus Vx minus 1 by 1. 1 plus Vx minus 1 by 1 plus Vx by 1 plus 1 equal to 0. Let me slide this left side. Yeah. Hope skin is stable to DS. Come on, tell me. 1 plus Vx by 1 by 1 plus Vx by 1 plus 1 equal to 0. Come on, what gets cancelled? This minus 1, this plus 1 gets cancelled. 2Vx plus 1 equal to 0. What is Vx, sir? Minus 1 by 2 volts. Vx will be reading as minus 1 by 2 volts. Clear? Right. So, Vx value is minus 1 by 2 volts, dear. Perfect? We have written the answers for this reference point. Let us change the reference point. Why? Examiner is asking for this reference point, na? Okay? Right. Yes, tell me please. Please write. Let us write the answers first. So, this node voltage is how much we got, sir? Minus 1 by 2. This node voltage is 0. This node voltage minus 1 by 2 we got. Now, to make this minus 1 by 2 0, what you have to do? Add plus 1 by 2. 1 by 2 if you add, how much? 0 volts. Perfectly matched. 0 plus 1 by 2. Here, plus 1 by 2. What is voltage? 1.5 volts. What is voltage, sir? Perfectly 0.5 volts. Clear, dears? This is how we can do the problems, dear. Okay? Right. Come on, tell me. Network subject, mesh analysis over, node analysis over. We have done with some previous gate questions. Easy or difficult, dears? Easy or difficult? Easy, dears. Practice for one time. You will get perfection. Done, dears? Right. Thank you. All the best.